Today we're going to discuss Chapter 3.6, Chemical Equations. What is a chemical equation? A chemical equation is a physical written representation of a chemical reaction. This is an equation that is written using chemical formulas. There are two main sides of a chemical equation, the reactants and the products. These two sides are separated by a yield, which is an arrow. And they can be seen in this example right here. It's a more complex chemical equation, but it shows the states that each side, the reactants and products are in, and it shows an example of a coefficient and a subscript, which we'll talk about later. So on the left side is your reactants, and on the right side is your products. So we're going to go over in depth the parts of a chemical equation. So the reactants are the starting materials in a reaction. That's on the left side. That's what you begin with. And these are the materials that are used in the reaction. So they're not changed, but they're moved into the product. The product is the ending side of the reaction. That's on the right side. And that's what's formed through the chemical equation. So here's an example, and what we're going to do is we're going to label the reactants and products. So we said the reactants are on the left side and the products are on the right side. So that means that the left side of the arrow is the reactants while the right side is the products. And also we know that the left side of the reactants are what's used in the chemical reaction, and it forms the product in the chemical reaction. Okay, so the last example that was down at the bottom, we're going to look at in a little more detail. This is methane combustion, but it's also an example of a balanced equation. So during a chemical reaction, atoms are neither created or destroyed. They're just moved in like the way that they're ordered. Because of this concept, the chemical equation must always be balanced, which means that the reactants must be the same as the products. And in the above equation, it's balanced because there is one carbon on each side, there's 4 hydrogens and 4 oxygens between this and then that. But we'll talk about the subscripts and the coefficients in a second. This is an example of an unbalanced one. So in this equation, we do have 1 carbon on each side. However, we only have, we have 4 hydrogens, but we don't have the same amount of oxygens. Where right here, we have just 2 oxygens on the reactant side, and then on this side, we have 2 oxygens right here, plus 2 oxygens on this side. So on the product side, there's 4 oxygens, on the reactant side, there's 2. Okay, so for the coefficients, a coefficient is the number that is found in front of the compound on either the reactant side or the product side, or even both. And it represents the number of molecules of that compound in the reaction. So right here we have a coefficient of 2, and this 2 represents anything that's behind it has 2 of them. So there's 2 of each of these elements, and right here there's 2 of this element. Okay, and then the subscript is kind of the same concept, but it's different. So it shows the number of atoms that are present for a single element, not the whole compound. This is written as a subscript below the letters and to the right of the element it represents. So right here, the subscript is tied with oxygen. It's written to the right below it, meaning that there's 2 of just the oxygen, whereas the coefficient represented everything that followed it, so it represented 2 elements, where this only represents the element that it's attached to.